start, before we get into anything more, this word muggles. Does everyone know what that is? Put your hands up if you don't know what that reference means, that muggles thing. You're in good company if you don't know what it means, because I am one of those people, or was one of those people. My colleague Martin Kern, he talks about this. Apparently it's from Harry Potter. Yeah, I'm not for sure. I'm not particularly into Harry Potter, I'm afraid, but I once rented Harry Potter by accident from a DVD vending machine. I wanted Zoolander. Accidentally got that one. But muggles means people without magic, apparently. That's what it means. So the idea of machine learning for people without magic, and of course if you've seen Harry Potter, that title makes perfect sense anyway. The concept of machine learning is roughly what I want to be talking about, but I'm a web developer, I'm not a data scientist, or I'm not into machine learning in any specific way. But there's a whole sort of group of just thousands and thousands of APIs which are coming out from companies like Microsoft, like Google, Deep Learning, and from IBM, which are making the concept of machine learning much more accessible to regular web developers, people like me. And I kind of want to show you for the next 20 minutes, roughly, the sorts of things that you can start doing with intelligence and machine learning inside of your applications. And it's pretty straightforward, the stuff that you want to do. Now, machine learning, traditionally, is this. Well, it's a rough definition of machine learning. It's finding complex patterns in data which allows applications to gain insight using new data, insights into new data using those patterns. So, in its sort of simplest terms, think of it as Amazon's recommendation engine. So, Amazon will have lots of sales data and lots of sales information at their disposal. They process that using machine learning, and then anyone which is looking for a new product, they can put that through their machine learning algorithm, and it will output recommendations for that user depending on what they bought. And the recommendations will be as good as the data that they have to train their algorithms. Sometimes it's really good, it can make recommendations for you which are really observant, and you absolutely might want to buy a HDMI cable with a TV. But sometimes it can be particularly ridiculous. Once got offered a Spider-Man costume with a HDMI adapter. So it's not that obvious, and it depends on the amount of data, but the idea is that machine learning is adding smarts to your application. Machine learning for Amazon, in that simple recommendation, it's changed them from being one of the online retailers to being world dominant. And machine learning is all around us. Everything that we develop, or lots of big tech companies develop currently, uses machine learning in its design process. So, for example, in Microsoft we have a thing called the Kinect device. No one ever taught a Kinect device that swipe left, swipe right is. No one ever programmed that as an algorithm. No one ever looked at movement of RGB data and figured out left and right. The way that we programmed the Kinect to understand swipe left and swipe right was we fed it just tons of data of people doing certain moves, telling them that was left and that was right, and then it figured out an algorithm to determine whether it was a swipe left or swipe right. It does stuff like gaze as well. Everything which a Kinect can do and understand about human skeletons is roughly from machine learning algorithms. No one ever wrote an algorithm to determine those sorts of things. Fraud detection may be in your bank. If you're using your card, your debit card or credit card in another place or another town, then it might just flag up. You know what? This is abnormal. It recognises that it's abnormal, and then alerts the bank that there's an abnormal activity on your account. That's machine learning. Machine learning is the idea of finding patterns in data and then doing something with that pattern, with that data, when we have new information or new data which comes into our system. This is the kind of things that machine learning applications, fraud detection, like I said, revenue prediction, customer churn, recommendations, predictive maintenance, computer vision, understanding what's in an image or what's in a video, or allowing a computer to understand or spot objects. We use it in search, obviously. We have our search engine thing. There is other search engines available. And natural language processing, sentiment analysis. When someone speaks, or when they write on Twitter, or perhaps when they speak to Alexa, or sentiment, is that a negative comment that user's making? Is it a positive comment? Are they getting angry with Alexa? Sentiment is used in all sorts of processes to figure out what that device should do.
I can't find the answer to the question I heard.
Don't worry about it. Motion detection, figuring out if cameras have moved and so forth. Translation, we have now not just text-to-text translation, but it's something like Skype. We use machine learning to be able to do real-time video and audio translation. So someone which is speaking in French can be translated directly in real time to someone speaking in English, and that's available as a technology today. And all of these things have been used by big technology companies with $1 million research budgets to make products really, really great and better. And the problem is, though, to get into this world and to do this stuff, you do need a PhD. You need to be, you need to have probably a research grant, you need to have loads of money, you need to have lots of people which are very smart with data to be able to build your machine learning algorithms and models. But there's this revolution which is happening. It's this democratization of artificial intelligence and machine learning, which is being led by Microsoft, IBM, and Google, amongst many others, allowing you to kind of get insights into your own data and then create smart applications based upon that. And that's roughly what I'm going to be speaking about. Because I'm not really a data scientist. Now, everything I show you today is going to be on this website, microsoft.com/cognitive services. The first one is emotion, and I'm going to be enlisting the help of my friend Johnny for this one. Johnny runs a conference down in Brighton, which is the last time I gave this talk. And what we're trying to do with this is, it's interesting. There's machine learning algorithms which will tell you where that face is. That's really useful inside an application. Inside of a video stream or a picture, where is the actual location of the face? And it's much harder a problem to solve than you might imagine. If you're trying to write an algorithm to do that, you might try and say, well, okay, I can maybe spot where the eyes are because of the colour differences, or maybe I can figure out some kind of shape in the image. But actually, writing an algorithm which just finds the face is really difficult. The way that you do it in machine learning is you tell a machine roughly where the face is in an image enough times to the point where it generates its own algorithm that when you then feed new images of faces, it's able to locate the face in those images. Face detection. It's been around for years. It's in all of your phones. If you ever open up a camera on your iPhone or Android device and you take a picture, it will be doing real-time face detection on that phone, on device. It's a well-known, well-understood problem. It's been solved for quite some time. And it's getting better. It used to be the case that the machine learning for face detection was racist. Like, it wouldn't notice people of different ethnicities and different skins if it had only been trained, or the algorithm had only been written against a certain group of people. So certainly the first face applications on cameras could only recognise white people, which is particularly poor given the world that we live in. And if you're looking at making a product like Windows, it obviously is used in something like hundreds of thousands of countries around the world. It needs to be able to take faces in all those different countries. So machine learning is solves the sorts of problems that you just can't write an algorithm for. So this is John, but not just figuring out where his face is in the picture. We want to determine what his emotions are in that picture. And so we have an algorithm up in the cloud where you can upload any picture or any video, and it will come back. You do a HTTP request post up to a service, and it will come back with a JSON response telling you where the face rectangle is in that picture, and also then the scores of the emotions of those users. It's particularly, so in this example here, he's got a certain degree of anger, a certain degree of contempt, there's some fear, but it's overwhelmingly he's neutral. So we built a little website, howhappy.co.uk. Oh, not connected to this one. Try and upload that picture. So it's found two faces, and we've sorted them by happiness. And that's what it does. This particular website can find 65 different faces in an image. And then you can start asking it questions like, who is the second happiest? F off, right, seriously. Right. A bore. How happy is a website? You can try it when you've got perfectly good internet. But what it will allow me to do in that image, that little text box, it will allows me to ask sort of real-time questions where I can say, who's the happiest person in this image, who's the second happiest person in this image. It will recognise 65 different faces, so you can find the 31st happiest person in an audience, or the most in the audience, or the saddest in the audience, and be able to pick them out. Apologies for that. I was going to take a picture of you guys, but I think that I'd probably leave that. So, I've actually got a slide. Which shows roughly the same idea. So we can figure out and we can sort it by different things. And this is calling that API. It uploads the picture to my service. It goes to our machine learning algorithm. It comes back with a simple JSON response that we can then use inside of our application. It's quite straightforward and simple. It also does things like computer vision. So over here, I've uploaded a picture of a man swimming, and it's telling me some information about the image. It's determining that the age of that gentleman is 28 years old and that he's male. And it's saying stuff like, it's a man swimming in a pool. It gives me that information. It figures that out by looking at the image. This is what we call computer vision. It's telling me that it recognises water with a 0.9% confidence, sport, swimming, sport, name, water, confidence. I use this particular service in my own web applications when people using my CMS don't upload descriptive information about their images. So they maybe upload an image of something to the CMS, but they don't include the information which I would ultimately put in the alt tag for my website. So I use this to go and determine roughly what the picture's about, and then add that to my CMS so that it has that information in the alt tag, so that people which have poor visibility or can't see are able to at least get an idea of what that image might be. But there's all sorts of things you can do with this information. We created a website called How Old, which took off on this. There's an iPhone application for it as well, where you can pick pictures of people and it'll determine the person as well. It's not particularly good because it keeps saying I'm older than I am. But we also built in our team a little bot called CaptionBot.ai, and CaptionBot.ai basically wraps up this little service. So we upload an image to it, and it gives it a nice little version of that same JSON thing, but it just puts it onto a web page. Where if I upload this picture of some seagulls, so I think it's a flock of birds flying over a beach. Interestingly, that caption bot can also do a couple of other things. We've trained it another few ways with machine learning as well. It can recognise any type of dog breed. So if you upload a picture of a dog, it won't just say it's a dog. It'll tell you what breed of that dog that is. And it also recognises celebrities. I say celebrities. If you're on IMDb, you'll recognise it. It's relatively accurate. But the concept is, if you never need to get information from a video or from an image, you can use these machine learning algorithms. We can also use the information to determine whether two faces are similar. And this is used in security applications, and this is what Uber use in their system to determine if the driver with the actual Uber application is actually the person which registered with Uber originally. They take a picture of their face, and it determines if it looks biometrically similar to the person on the database. And if it does, it will allow them to log in. We have this built in 10 as well. If you have a webcam set up on your machine or built into your machine, instead of entering a password, the Windows 10 will recognise your face and automatically log you in. It uses this same sort of technology to do that. And we use the same technology to do something different. We're on a website called twinsonNot.net. And this allows you to upload a picture of yourself, or any two people really, and see how similar they are. So I am 68% the same as Freddie Mercury, which I quite enjoyed.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So Geek, not only is it awesome, it's a great idea, it's a great use of machine learning and some of these APIs, I just find it amazing that you can use Visual Studio without being able to see. Whilst Sakib is kind of doing these really awesome things with technology, I was yet again wasting my time on ridiculous demos. So we built, or people on our team built, a project called Project Murphy. And we set about answering serious questions like, what if I had a beard? And we created a bot, and we added Skype into Facebook Messenger. And the idea of this bot is that, much like the name that I shall not say, that device there, is that this bot ours is text-based inside of Skype, and you send requests over to the bot, and it responds back to you. So, for example, let's just see. I'm in Skype, and I just sent a thing over saying, "What if I had a beard? What if I had a beard?" Which is easy. And basically, what it does is it takes images which it knows of me. It then adds some extra stuff like it figures out what a beard looks like, and then it munges together my face with a picture of a beard. And you can ask it any question. You can ask it, what if Beethoven was a rock star? What if I had a beard? What if I was a woman, if you ever want to know that? What if I was a man? What if I looked a bit like a trendy David Beckham? You can ask it any question, it will visualise me. That was my favourite beard version that it came up with. It's an impressive beard. If I could grow one like that, I would. The idea of Project Murphy, if you've got Skype or Facebook Messenger, you can add it to there. And you can speak to Project Murphy and ask him to generate visualizations. What if I had a beard? What if I was 8 foot tall? What if Martin Beeby was Jon Snow, the newsreader? Because I was trying to tell Project Murphy at this point, I don't want Jon Snow from Game of Thrones, I want Jon Snow, the newsreader. Because it kept on coming up with Jon Snow, Game of Thrones. I was like, I don't want that one. So what it instead came up with was Jon Snow from Game of Thrones in place of Jon Snow, the newsreader on Channel 4 News, with my face on it, which I thought was particularly amazing about that application. I'm pretty happy with the outcomes, in all honesty. This is one of the most spookiest versions of things that I've asked on. What if Hillary Clinton was Donald Trump? I think that looks like a person. It's really scary. But it's this imagination bot. The idea is, it was the first bot that anyone in our team had written, and the concept was, we just need something, we need to build a bot. We didn't really have any data, but we do have all of the images on the internet, and we do have people using Skype. Let's meld them together and build this thing. So it's our first rudimental bot. You can speak to it, it produces stuff. And nothing we do with this particular bot, we're not doing any data science or machine learning or analysing images ourselves. We're all just using these APIs, these Microsoft Cognitive APIs. We're not doing any of this stuff ourselves. I'm not doing any data analysis or machine learning like I would have to. One of our partners, we showed them this, I showed them those sorts of demos, and they said we could do actually something which is useful with that. So they built Skyscanner bot. So if anyone used Skyscanner, that's all. So it's if you don't use it and you go on any kind of flights, you should use it because you'll save loads of money. Skyscanner allows you to, it's a comparison site basically for flights. So you say you're from and to destination, and then it will come back with information. Now, Skyscanner want to get into this bots business, and they wanted to make sure that they were on Facebook Messenger, they wanted to be on Skype, they wanted to be maybe even in things like Slack or that one which I can't say. And so what they did is they built using a thing which we have called the Microsoft Bot Framework, which supports all of those different platforms, Facebook Messenger. This one will be coming in 3 or 4 weeks. And but this is the example inside of Skype. So I'm inside of Skype and I say to it, tell me your destination, Amsterdam. You're going to Amsterdam, Netherlands. Where will you fly from? Luton. You're flying from London, Luton, United Kingdom. It will ask you a series of questions which will generally figure out where you're going and what you're doing and when you're going away. And then ultimately it will come back with information about your flights. And the biggest challenge here starts to be understanding human language. Because that's actually, it's really easy on a website when you have a text box and you tell people what they have to type in there, or a button that they have to press where they have an option. But when you're actually allowing people to do free-form text entry, things start getting really, really tricky and complicated. And so, for example, when you're speaking to Skyscanner, we ask questions like, when are you flying? But if the answer isn't next week, we're not going to cry and the Skyscanner bot's not going to break down. What we're going to try and do is figure out your intent. So you can just go in there, it will say, where do you want to fly from? But you could say to it, I want to fly from Glasgow down to London in a couple of weeks' time. I want to go from Glasgow to London in a couple of weeks' time. You can just say it's one sentence in any order, and it will figure out what you meant, and then present you results. That's the hardest part of writing one of these bots. It's the hardest part of writing a bot for that as well. It's not just trying to figure, there's some commands that you can give that particular device in certain ways that you structure stuff. But the next versions of these kinds of technologies and bots and stuff is going to be, the thing which is going to be make or break for these technologies is whether they can just understand natural language and understand that. And again, that's something which we offer a service for as well. So if you do want to build one of these bots, we currently are available on Skype. Amazon's platform is coming in a couple of weeks. Skype, Messenger, Telegram, Geek, and Slack at the moment. There's a few other ones, but they're certainly the main ones that we're getting information from. The idea is you build one bot, and it can speak on any of those platforms, including that one. So the thing is to try and understand is language understanding. That's the hardest part about these bots. And if we look at that Skyscanner thing, please tell me the city you'd like to go to. Instead of answering that question directly, what there I've done is said, I'd like to book a flight to London for next weekend going from Glasgow, as I was saying earlier. You might not get the response you expect if you're building a bot to what the question that you asked. But it's able to it's able to figure out what you said. Disambiguate, is that the right word? Disambiguate the word to figure out what you meant London from Glasgow next week. It can figure that stuff out from that natural language. And the way we do that is we use a system called Lewis. And Lewis is a language understanding intelligence service. I'd like to book a flight to London for next weekend going from Glasgow. The intent of that is book a flight. That's the important aspect of that. The following weekend, I'd like to travel to London from Glasgow. Again, that's the intent, to travel. Completely different ways of saying the exact same thing, but a bot needs to understand both of those and many more different ways of saying it. My dad has a particular way of speaking to computers, and it's this way. It's not those kinds of natural language, he doesn't trust computers. And this is how he searches Google as well. Bing. This is how he searches Bing. London! Glasgow, flight, weekend, thank you. Thing is about my dad, he's very polite. He always adds thank you on the end. London, Glasgow, flight, weekend, thank you. Intent is fly. Yeah, it's the same thing which he means. And all the information's there, it's just said in a weird way. My dad speaks weird. London, Glasgow, flight, weekend, thank you. It's not even Scottish. But, the other important aspects of those sentences are the entities, or the variables. So if we know the intent, we can match that to a function in our application. But that function may have variables. So to get the variables extracted from the sentence, we would need what we call entities. So using that conversation now, to London, next weekend from Glasgow. From that information, we can figure out, what we need for Skyscanner. And then following weekend, I'd like to travel to London from Glasgow. Now, the thing that Lewis is also going to be able to do is translate the following weekend and next weekend into dates. because that's important to know the context of that, and we wouldn't want you to have to figure that out yourself. So when you say first, or when you say any kind of date or reference to a date next weekend, next Tuesday, it will tell you, or the service will come back with what date they meant, not the textual words next weekend. Likewise, if you said, tell me the third happiest person in that picture, we'll send back a JSON response which says they want the third person, not just the text third or third spelled however it would. So we're able to, with entities, extract information from the sentence, but then also convert it into information that you can then use inside of a program. And with my dad, London, Glasgow, weekend, they're the important parts of that, and thank you, you can just throw away because it's nonsense. Computers don't care if you're happy or not. So, this is the, I showed you that how happy they were, which didn't go particularly well. This is our Lewis model for that. So Lewis is basically a website that you go to, and you build a language understanding model without having to know anything about data science. And this can be used in bots, but it can also be used in any place where you want free-form conversations to happen. So if you're writing telecom systems, you might want to use a system like this to understand what people are saying to you. If you're writing websites where there's a search box, you might want to get that information here. If you're building an application which can accept information from the mic, then you might want to, from the microphone, you might want to use this service to understand what your users are actually saying to your application and their intent. So what you would do inside of Lewis is you set up your intent. Think of these as functions. So in the instance of my application, or how happy, most emotional. So if you ask it who's the most happy, it will figure out that it means that function. Who's the happiest? It will sort it by emotion. Who's the third happiest? Is the function is the specific person. And who's the least happiest? And it will tell you tell you that information. We also then have entities as well. And in my specific use case, I've got emotions because I need to detect all the different emotions that someone's going to be potentially using. So who's the happiest? Who's the saddest? Who's the angriest? What we then do is we provide the system with utterances, which is examples of words or sentences that people have said to our application before. So for example here, an utterance that I used to train this model was, who is the fifth saddest person? And what it does then, it figures out what function it thinks that utterance is in, what the intent of that thing is. So it's saying the intent is the specific person. And then it's also highlighting this thing in yellow, which means it's figured out that that's an emotion as well. You could misspell sadness, you could spell it in a funny way, it would still pick up that that's sadness. It's still clever enough. It doesn't have to be exact words here. It's using machine learning to make sense of ambiguous sentences. The more you train it, the more utterances you give it, the better it can start understanding human language. And then you basically will go through each utterance as a developer and say, actually, when you determined that that was an emotion, actually that wasn't an emotion, that was something else, that was another feature of my application. And when you said that it was going to the specific person function, that's wrong, yeah, actually it should go to this particular aspect of my application. So you train the application with all these different utterances. What that then does is creates a model in the cloud for you, which you then can just call as a REST API. So this is another example of me giving it another utterance. And that RESTful API is just a HTTP web request, api.project.oxford, Lewis, application 1, is my application key. And then we type in our query to that URL. So obviously any application now can call this model if it can call the internet, which is something I'm having problems with this afternoon. And the response that it gets back will be this. It's a JSON string. Well, let me just try and zoom in. It's a JSON string. I've accidentally misspelled this query. I said, how is the fourth happiest? How is the fourth happiest? Which should have been, who is the fourth happiest? But it's still figured out, it's 89% certain that that sentence, the intent of that sentence, is to find the specific person in the image. And then it reckons that of all of the different functions, the intents in my application, it's saying that, I think it's that one, so that specific person is 80%, most emotion is 0.5%, 0.006% that it's none, and 0.007 that it should be supported by emotion. So as a developer I can say, actually, they probably want this function here to find the specific person in that image, which is correct in that instance. And then it's giving me a list of the entities from that conversation as well. It's figured out, I've said the word fourth, so it's figured out that's an ordinal, and it's 90% sure that it's the fourth ordinal. And it's located at 11 characters in, and the instance ends 13 characters after. So it recognised that the entity is the fourth thing. It's also figured out the emotion, and the type of emotion as well. So it said that person's looking for the happiest, whatever they're looking for in this image. And it is 80% certain that the emotion it's looking for is happiness. And it's building these systems together and training this model. You can start building things like the Skyscanner bot. You can start building applications for things like that. This one's set up to recognise that name, but I think you can also say Amazon as well. It doesn't pick that up unless you've trained it to. But so Amazon will listen to you speak, and if you build an Amazon, if you add a skill to the Amazon Echo, you might want to be able to listen to the user. They'll convert it into text for you. You can then take that text and then analyse it in something like this system, and then find out what that user actually wants to do. And that's exactly how it works. But they've spent billions and billions on research to be able to understand human language, and people like Microsoft, IBM also have services like that, and Facebook now as well do as well. Where these big technology companies are making these things very accessible to regular developers out there. If you're able to call a RESTful endpoint, then you can call any of these services. So that's me. I'm Martin Beeby. That's me in one of our offices already, actually, wearing one of our Halo things. I'm available with the Beebs on Twitter, and I'll link out to the slides and so forth afterwards, if you're interested in it. And if you're looking at being able to figure out any of these services or what you can do with them, if I've got an internet connection now, Microsoft Cognitive. You can go to the Microsoft Cognitive website, hopefully. No excuses, there you go. It's a little bit thing. And we have all sorts of different APIs that you can use. I've only covered on like 2 of them, emotions and computer vision. We have tons of these things. We can build a recommendations engine for you if you have a product database. You can upload all of your products into there, and we can start building recommendation stuff into it. And we can start doing speech recognition. This demo never works, so let's try it. Every other demo's failed today, so let's just see if this one works. Yes. Hello. Yeah, that's failed as well. That's great. Never mind. That always fails, though. I expected that one to fail. It never fails when you're not projecting, but for some reason, Windows machines, when you're projecting, they read the microphone differently, and that's why the microphone doesn't seem to work on there. Maybe we could do text-to-speech. Hello. No volume. Yeah, having a great time of this stuff. Let's see if I've got another idea, which I can see. The things about computer vision, what I was talking about there earlier as well, you can upload any image, it says, and it will tell you the information about that. And you can test it yourself. You can just open up any image and upload those images, and it will analyse them and tell you what's in them. Hopefully. Crowd of people standing on top of the building, interesting. It's got a level of confidence of 0.1% confidence of that. It recognised that it's 0.9% confidence this is a picture taken indoors, and it's a 0.6% confidence that there's people. And depending on the threshold of your application, you will determine whether or not that confidence level is good enough or not good enough for your application. That's the idea of these cognitive services. I'm sorry that practically everything which I showed you today didn't work, but never mind. Is there any questions at all about any of these services?
There's a start point. These are open, it's free to start with.
Yeah, or practically every single one of these is open and free to start with. So if you look at the bottom of all of these different things, where are we? So up to 5,000 transactions, so that particular image one is free, and then over that there's £1.50 per 1,000 transactions, and different APIs will require different requirements. But we do all sorts of things, like there's an example of getting text from an image. That's a particular thing which lots of people want to be able to do. I was helping a friend of mine who was having a race where he had loads of images of people doing this endurance race over a 24 hours period, and they were all wearing these bibs with numbers on them, and he had like 4,000 images, and he wanted to just tally up those images with the actual people which were racing. So we put it through this system. We pulled out, or we OCR'd all of the numbers on those people with bibs, and then we were able to quite easily categorise who the images were and who the people were in those images. So being able to understand or take text from an image and then convert it into actual text, which you can't actually see on the projector, but never mind, which is quite a straightforward thing to do. And we can do everything which we can do from images, we can also do from videos as well. So there's another question just from over there.
Yes, you might have already explained before, perhaps. When you built your Lewis model, you don't have to train that within days, that's automatic.
No, it does, you have to train it. So you have to say, it doesn't take long, maybe 5 or 6 utterances, and it will get the gist of what you're trying to do. And depending on the complexity of what the kinds of things that people ask, it will be more or less complex. So the thing is as well about that is, when your API is live and people are using it in their application, there's also a page which shows you all of the questions that the API has been asked. And then it tells you the results of all of those questions as well. So you're able to then not only just provide lots of utterances that you think of, but when your application's out in the wild, you can then go and test each individual, go and have a look at each individual sort of API call, basically, and say, did that go to the correct function, and then retrain it based upon that information as well. So the cool thing about Lewis is it's constantly learning. The more people choose your applications, the more way they ask different questions to your applications, the smarter and smarter it can get. And that's the benefit of the machine learning algorithm, which should constantly be learning and constantly get smarter.
Does it also do anything about where you are in the context of the conversation? Does it sort of remember what you've already said, or figure out that you want a different flight now and that you're a whole different destination today?
So the way that we do that in Skyscanner is that's what the bot framework does. So we have this thing called the bot framework, which I put the URL of. Bot framework is all about understanding the state of the conversation. Lewis doesn't necessarily know, or doesn't know, what you last asked it. It's a very dumb API in that sense. It will just try and find the intent and information about that. It's up to the developers then to figure out, okay, I know what you previously said to me, that this is the current conversation, so I know roughly what he might be. He's probably going to be asking if one or two of these different options. You then use Lewis to maybe disembank it, to tell you the difference between what's in there. And then, but yeah, it's up to the developer to add some of those smarts. But the bot framework is all about, if you're trying to maintain a conversational state, that's what bot framework is intended for. Lewis is just purely for understanding specifically a piece of text that's given to it. Get intent from it.
Is it restricted to English, or can you try it in other languages?
It's available, that Lewis is currently in private preview. I think we're available in about 7 languages at the moment. Generally, the way that these services are built up, it's like our translation service, that's available in like 50, I think, now. But they start off usually with the European language. English, obviously, because people with debit generally from Seattle, so they speak English. Then they'll pick generally like a European language, like French or German. Then they choose Chinese, because that's a difficult language. And German's a very difficult language to do any machine learning against, because of the way that German's used. And then they'll take a right-to-left language as well. So generally when these services come out, they'll probably have like 6 or so languages that they support. And then as they become more developed, we then add more and more languages based upon that. But yeah, most, I don't know how far Lewis is, but it generally has, it definitely does more than just English. But obviously, it won't support every language that you might want it to. So, anything else? Oh, sorry.
When you're training Lewis, can you actually expose the training itself via the API?
No. So it's a black box in terms of, and this is actually really interesting. With there's an EU directive in 2018 which says that that you have to prove for an end user which is using your product, you have to prove why a certain decision was made. So you have to have auditable trails of decision making inside an organisation. So this will prove real problems for financial organisations at the moment, which are using machine learning to do things like credit checks. Because actually with machine learning, you often don't know why the decision was come across. Why was that decision made? With something like Bayesian learning, you can figure out the tree and the reasons why that particular decision was made. But in lots of machine learning algorithms, you can't actually figure out why did it come back with that result. It just comes back with that result, but you don't know necessarily why. You can guess, and you can figure out you can run some tests and figure some stuff out generally, but with very deep machine learning networks, they're so complicated that it's almost impossible it's impossible to figure out some reasons why that decision was made, and what particular piece of this data influenced that. And so there's only certain applications of machine learning where that's going to be really tricky, because to be able to comply with that European regulation in 2018, certain financial companies we don't know why that person got refused credit. Our system just says, our machine learning algorithm just says they should be.
So I've got a specific problem I want to solve.
Yeah.
So I've got one company's list of products, I've got another company's list of products. Using only the product's name, I want to match the two together.
Yeah.
Now, doing word matching is only very vaguely so what I'm looking for is, in something like this, is there the opportunity for somebody to say, right, this is my product catalogue, so this means this means this.
Yeah.
So that means the end user themselves doing the training for their own instance.
Yeah, so what you'd be thinking is, the end user as in, what would be probably easier to try and solve that kind of problem is if you took your if you've got search information available of how people ended up buying those products. So you can see what they searched for to get those products as well. And then maybe it wouldn't be Lewis which would help you with this problem. There is a knowledge graph API which could help you perhaps with that issue. For problems which are very specific and you want to do a very specific thing, there's a thing called Azure Machine Learning where you can actually start building your own models. They're more complex, it's more difficult to use, and you have to do, it's not just calling an API. It ends up being just an API that you call, but the training aspects of it and the setting up of the model requires a little bit more investigation. But I've built machine learning models. It's a drag and drop interface. It's not that difficult to use, but it's exactly for that sort of thing. As long as you can sort of throw enough data at it with examples of things, machine learning is usually able to answer those sorts of questions, those sorts of problems. I'm more than willing to help you if you're wanting to look into that sort of problem. I can help you and put you in touch up with one of our data scientists to show you how you would solve that sort of problem with machine learning.
Yeah.
Amy and our team is really good for that sort of thing. You can ask the question of that, but if you've got the data, ultimately you can answer most questions. Yeah.
So what is the advantage of St. Louis? We have this Facebook, we have Siri, we have this Watson, we have many things. So what's the advantage of Louis when compared with other?
Watson's probably the closest thing you could compare cognitive services with Watson. So IBM are doing a really good job of deep neural networks, and there's also some really good work happening at Google and their deep learning team. And basically these are fruits of the labour. This stuff changes constantly. The APIs that we offer, that Watson offer, we have the most accurate, depending on the API, we have the most accurate speech recognition of any of them. We have, I don't think they offer an exact service like Lewis. Facebook do. They have some kind of, and I've not used it, so I don't know how good it is. And I'm not even sure if we've done a comparison to them. But there are definitely other companies which have got these services. Very few of them are yet as broad of the thing we've got here. And we've been investing in this area for an awful long time. If any of you know Cambridge, we have a whole team in Cambridge. This is the majority of work which you see in these cognitive services happened in the UK out of our Cambridge research team. And to give you an idea of the level of investment in research, we spent $8 billion on just this kind of research every year. So it's an expensive game to be in, and that's why Microsoft, Google, and IBM were really. Google just bought a company called something.ai. I can't remember what they're called now. They were really good. They offered a very similar service to what we do in different APIs. But all the APIs do slightly different things, and they're used for different scenarios. We're not the only ones providing these services, but we certainly have one of the biggest collections of things that you can do with it. And most of them are free.
Just one last question. On Louis, so is it possible to define one say custom it's in custom intents, like because you showed us this diagram where we have to choose and from predefined and it's predefined entries.
Yeah.
So, and now my question is it possible to define my own intents, my own?
Oh, sorry. Yeah. So all those intents were my own in my application. You can have up to 200 different intents from in one single API. So they're basically matched to functions in an application. My application has 6 things that it can roughly do. So I just need to figure out which one of those 6 things it wants to do. We previously had a upper limit that you have 10 intents, but now you can have up to 200. So and you train it with your own language, your own utterances, your own entities, your own things that it finds inside of natural language. It's the idea of taking free-form natural language and converting it into actionable information.
Okay, great.
Cheers, thanks.
Martin, thank you so much for that. That was excellent. Obviously, lots of questions on that. We could keep going for a long time, I'm sure. So if you've got any questions, please grab Martin. He can answer those. We're going to stop now for a bite to eat. Now we've got 35 subways just outside that door, so we've got a bit of us.
I was thinking, I can't see them. I'm going to have to phone someone at Subway.
They're here, and they very kindly donated by Microsoft.
To tell you the process of that, I sent an email to Redmond. They sent a request to Subway, who then sent an email over to India, who then sent an email back to the US, West Coast US, who then sent an email to Northampton store, who then sent an email to me to say, yeah, we'll order 35 Subways. But that was the email chain which went there to order 35 Subways.
$3, I was thinking, dollars. It's only Kingston.
It's amazing.
Okay, so what we're going to do is we'll break then. Hopefully, I think we're looking at numbers, we should be all be good for something sweet. So we'll bring them in, say, we'll just chill out for 20 minutes or so, have something sweet, and then we're going to get going again with Mark.